In the earliest days of human civilization, before the thunder of cannon fire and the distant silhouettes of ironclads, the sea was both a barrier and a highway. The world's first mariners gazed out upon restless waters, seeing not only a source of sustenance but also a stage where power and survival would be contested. Along the winding coasts and island chains of the eastern Mediterranean, the story of fleet warfare began to unfold, a story shaped by ingenuity, necessity, and the relentless pursuit of supremacy. The birth of fleet warfare cannot be traced to a single moment or culture. Instead, it emerged gradually, molded by the needs and ambitions of the earliest maritime societies. In the ancient world, the sea was a place of commerce, exploration, and, inevitably, conflict. As settlements grew into city-states and commerce flourished across the Mediterranean's blue expanse, the need for organized naval power became increasingly apparent. Fleets did not simply appear fully formed. They evolved from humble oared boats and simple raiding parties into sophisticated instruments of war and policy. Ancient sources suggest that the first organized naval clashes were driven more by survival and plunder than by grand strategy. Early seafaring peoples, Phoenicians, Mycenaeans, and others, used their ships to raid, trade, and defend their coasts. As maritime technology advanced, ship-to-ship combat became more frequent and complex. The earliest warships were essentially modified merchant vessels, designed to carry warriors who would board enemy ships in close combat. Tactics were straightforward and brutal: close the distance, grapple, and overwhelm the opposition with superior numbers or skill. As cities grew wealthier and more dependent on maritime trade, the stakes rose. Control of the sea lanes meant control of commerce, influence, and, in some cases, survival itself. The rise of Greek naval power offers one of the clearest early examples of this shift. Greek city-states, fragmented yet fiercely independent, found themselves in constant struggle for regional dominance. This rivalry spurred innovation, most notably the development of the trireme, a long, sleek vessel powered by 3 banks of oarsmen. The trireme was not just a ship, it was a weapon, designed for speed, agility, and the ability to strike with deadly force. The Greeks' approach to naval warfare was shaped by both the technical development of their ships and the unique geography of their homeland. With thousands of miles of coastline and countless islands, the Aegean was a natural theater for naval conflict. The Greeks quickly recognized that victory at sea required more than brute strength. Early tactics focused on the use of the ram, a bronze-clad protrusion at a ship's prow, to smash into enemy hulls. Precision and discipline became essential as fleets maneuvered in tight formations, seeking to outflank and disable their opponents. Boarding remained a reality, but the trireme's true strength lay in its ability to deliver a swift, crippling blow and then withdraw before becoming entangled. Even as Greek naval power rose, the organization of their fleets remained fragmented. Each city-state maintained its own navy, with varying degrees of professionalism and coordination. Only in moments of existential threat, such as the Persian invasions, did the Greeks unite their forces. The Battle of Salamis stands as a testament to the power of organized fleet action. In the narrow straits, Greek triremes outmaneuvered a larger Persian force, demonstrating the decisive impact that well-coordinated naval tactics could have on the course of history. The victory at Salamis, scholars believe, was not simply a triumph of ship over ship, but of fleet over fleet, a recognition that control of the sea depended on collective action and strategic planning. As centuries passed, the lessons of Greek naval warfare echoed across the Mediterranean. Nowhere did these lessons resonate more powerfully than in Rome. Initially a land power, Rome's first ventures into naval warfare were hesitant and reactive, often relying on the fleets of allied cities. During the Samnite Wars, as sources indicate, Rome recognized the necessity of a fleet and began to build its own ships, learning from both friends and foes. The Roman navy was organized into squadrons, known as classes, each with its own command structure and responsibilities. This early example of fleet organization reflected a growing understanding that naval warfare required not just ships, but systems, training, logistics, and administration. Roman naval power reached its height during the Punic Wars, when the fate of the Mediterranean hung in the balance. The Romans, drawing on their organizational strengths, adapted quickly to the demands of maritime conflict. They introduced innovations such as the corvus, a boarding bridge that allowed legionaries to turn sea battles into infantry engagements. While the corvus was eventually abandoned due to its instability in rough seas, it epitomized Rome's pragmatic approach, adapting the tools of land warfare to the unique challenges of the sea. Logistics and management became central concerns. Fleets required vast resources, not only ships, but supplies, repair facilities, and trained crews. Ancient sources and archaeological evidence suggest that the Romans established networks of ports and depots, ensuring their fleets could operate far from home for extended periods. Maintaining these fleets was a daunting task, but one that Rome pursued with characteristic determination, understanding that sea power was both a shield and a sword. Over time, the nature of fleet warfare continued to evolve. The Romans shifted from offensive expeditions to patrols and anti-piracy operations, reflecting changes in both technology and geopolitics. The decline of Roman naval dominance did not mark the end of fleet warfare, but rather its transformation. New powers would rise, new ships would be built, and new tactics devised. Yet the foundational principles remained. Mastery of the sea required organization, innovation, and the ability to project power across vast and unpredictable waters. Throughout antiquity, the core tactics of naval battle ramming, boarding, and, in later centuries, the use of incendiary weapons like Greek fire remained central. Battle formations grew more sophisticated as commanders experimented with line and crescent shapes to maximize their fleet strengths and exploit enemy weaknesses. As naval warfare matured, the ability to coordinate large numbers of ships, supply them, and maintain discipline became the true test of maritime power. The birth of fleet warfare, then, was not a single event, but a gradual awakening to the possibilities and perils of the sea. From the first daring raids to the clash of organized squadrons, ancient peoples learned that the ocean was not merely a backdrop for conflict, but a force that demanded respect, ingenuity, and relentless effort. The rise of fleets, complex, coordinated, and formidable, transformed the ancient world, setting the stage for centuries of naval struggle to come. As the prows of galleys sliced through the morning mist, they carried not just warriors and weapons, but the very future of empires, written upon the ever-shifting tides. The dawn of the Age of Sail marked a new chapter in naval history, defined by sweeping masts and billowing canvas that carried fleets across the world's oceans for centuries. By the 16th century, the seas had become a stage for a dramatic contest of power, as European states competed to expand their influence and protect commerce. Fleets grew larger, warships became grander, and tactics more sophisticated. The galleon, with its towering stern and multiple decks bristling with cannon, emerged as the signature vessel of this era. Driven by the wind and built for endurance, these ships of the line formed the backbone of naval might, capable of carrying dozens of guns and hundreds of men. Their broadside barrages, rows of cannon firing in unison, transformed sea battles from close-quarters boarding actions into thunderous exchanges of shot and shrapnel. Technological ingenuity flourished during this period. Naval architects refined hull shapes for speed and stability, while riggers devised ever more intricate sail plans. The square rig, in particular, allowed ships to harness prevailing winds more effectively, propelling them across oceans and into the heart of rival empires. Gunpowder, once a novelty, became the indispensable force behind naval ordnance, and the introduction of explosive shells in the early 19th century would later render traditional wooden warships dangerously obsolete. Yet for all their grandeur, even the mightiest sailing ships remained at the mercy of wind and weather. Fleets could be scattered by storms or becalmed for days, their fate dictated by the invisible whims of the atmosphere. Admirals planned their campaigns around the seasons, and the limits of wind-powered maneuver meant that even the most brilliant tactics could be undone by an untimely lull or a sudden squall. The constraints of nature loomed large over every engagement, shaping both the strategies and anxieties of those who sailed into battle. In the 19th century, however, the winds of change began to blow with unprecedented force. The introduction of the steam engine was nothing short of revolutionary. Early experiments with steam propulsion had taken place as far back as the 18th century, but it was in the decades that followed that the technology matured and spread globally. Paddle wheels gave way to more efficient screw propellers, a development historians recognize as a turning point in both shipbuilding and naval operations. Steam power freed warships from the tyranny of the wind, granting them the ability to move against currents and maintain formation regardless of weather. This technological leap had profound consequences for the composition and tactics of fleets. Traditional sailing formations, so carefully choreographed to take advantage of the wind, became obsolete. Steam-powered ships could maneuver independently, hold the line, and concentrate fire at will. The crossing the T tactic, where one fleet would cross the path of another, unleashing devastating broadsides against the enemy's bow, gained new prominence, as steam allowed for the precise timing and positioning such maneuvers required. At the same time, advances in armament transformed the face of naval warfare. The evolution from solid shot to explosive shells vastly increased the destructive power of shipborne artillery. Wooden hulls, once sufficient to withstand enemy fire, now proved fatally vulnerable to the new ordnance. The response was inevitable: the ironclad warship. Armored with iron plates and powered by steam, these vessels could shrug off blows that would have shattered a galleon. The race to build stronger, faster, and more heavily armed ships became a defining feature of the era, as navies scrambled to integrate these technological marvels into their fleets. The first true test of steam-powered warships in combat came in 1853, when rival fleets met in battle and the old order of sail was challenged on the open sea. This engagement, though not the final chapter of the Age of Sail, signaled a clear shift. Steam was no longer an experimental novelty but a force to be reckoned with. Even so, sail did not disappear overnight. For many years, hybrid vessels carried both masts and engines, relying on canvas to conserve coal during long voyages and turning to steam for battle or when maneuvering in confined waters. Some cargoes, particularly those less urgent, continued to be carried by sail well into the 20th century, a testament to the enduring efficiency of wind power for certain routes and economies. America, too, experienced its own decade of transition. The United States Navy officially declared the end of its reliance on sails in the late 19th century, but the intervening years saw remarkable innovation. Early American steamships experimented with iron hulls and screw propulsion, and the Navy's first iron warships marked a new era in ship design. The concept of the steam ram, using the power of steam to drive a vessel into enemy ships, captured the imagination of naval theorists, though practical challenges limited its widespread adoption. As steam power took hold, new threats emerged. Mines, torpedoes, and eventually submarines appeared, forcing further adaptation. The old tactics of close engagement and boarding became relics of the past, replaced by gunnery duels at greater range and the constant threat posed by unseen enemies lurking below the waves. The rise of the aircraft carrier would later outstrip even the most advanced battleships, but that lay further ahead in the story. Amid these changes, the question of naval power's role on the world stage grew ever more urgent. Theories of sea power, most famously articulated by Alfred Thayer Mahan, gained traction among policymakers and admirals alike. Mahan argued that control of the seas was essential for securing international markets and projecting national influence, a view that helped fuel the naval arms race of the late 19th and early 20th centuries. His ideas, grounded in the realities of steam and steel, shaped the strategies of emerging and established powers, from Britain and Germany to Japan and the United States. The Age of Sail did not end with a single battle or invention. It faded gradually, its traditions lingering in the rigging of hybrid ships and the language of the sea, but the arrival of steam and the embrace of iron and steel marked an unmistakable break with the past. Fleets became not merely collections of fighting ships, but complex, interdependent systems, reliant on coaling stations, repair yards, and global networks of supply. Naval warfare had entered an era where technological innovation and industrial might were as decisive as courage and seamanship. If the old fleets had once moved with the wind, now they moved with the pulse of pistons and the roar of boilers. The transformation was as much about the mind as the machine, as admirals learned to think in new dimensions, to plot courses independent of wind, to deploy ships in ways their predecessors could scarcely imagine, and to wield naval power as a tool of global strategy rather than local dominance. The tides of maritime supremacy were shifting, and with them, the destinies of nations. The story of sail and steam is not simply one of invention, but of adaptation, ambition, and the relentless pursuit of advantage on the world's oceans, a legacy still felt wherever ships put to sea. In the early decades of the 20th century, naval warfare changed more rapidly and profoundly than ever before. The world's great powers, driven by industrialization, entered an arms race that not only refined old tactics, but also introduced entirely new ways to wage war at sea. The scale of these changes, fueled by industry, science, and the demands of global conflict, reshaped fleet warfare and set the stage for struggles that would span oceans and determine the fate of nations. At the center of this transformation was the relentless advance of technology. Mines and torpedoes, once considered novelties, became essential components of naval arsenals. Submarines, steely predators lurking beneath the waves, added a new dimension of stealth and surprise. Radio, and later radar, revolutionized communication and detection, allowing admirals to coordinate fleets across vast distances and pierce the fog of war that once concealed enemy movements. The adoption of these technologies, as detailed in studies of naval innovation, was neither uniform nor uncontested. It required vision, resources, and often the hard lessons of battlefield experience to turn invention into advantage. The First World War became the crucible in which many of these innovations were tested. At the war's outbreak, the world's navies bristled with new dreadnought battleships, massive vessels clad in steel, armed with heavy guns, and powered by coal and oil-fired engines. These ships, products of industrial might, symbolized national prestige and deterrence. Yet, despite their power, most spent the early years of the war locked in cautious maneuver or stalemate, wary of exposing themselves to the constant threat of mines and torpedoes. The vastness of the North Sea became a chessboard, with each side probing for weakness, laying traps, and launching sorties that rarely led to decisive action. Beneath the surface, however, the most far-reaching changes took hold. Submarines, especially those of the German Navy, proved far more disruptive than many had anticipated. With their ability to strike unseen, they overturned old assumptions about control of the sea. German U-boats prowled the Atlantic, targeting merchant convoys and warships alike, and introduced the chilling concept of unrestricted submarine warfare. The sinking of civilian and neutral ships intended to strangle Britain's supply lines raised the stakes and helped draw new powers into the conflict. In response, British strategists adopted the convoy system, grouping merchant ships under the protection of armed escorts to counter submarine attacks. This shift in tactics, supported by rapid industrial production of escort vessels and the use of new technologies like depth charges and hydrophones, gradually blunted the U-boat threat and highlighted the importance of adaptation in naval strategy. Industrialization itself was both the enabler and the accelerant of these changes. The capacity to build ships, weapons, and munitions on a mass scale allowed the belligerents to absorb losses, reinforce blockades, and sustain operations far from home ports. The United States, entering the war with formidable industrial resources, was able to mobilize and deploy a powerful navy that contributed to the balance of sea power. Mass production not only supplied the ships and submarines needed for battle, but also ensured the flow of raw materials and food that supported the war effort on land and sea alike. The scale and devastation of World War I were inseparably linked to this unprecedented mobilization of industry and technology. Yet, even as the war ended with the dreadnought still a symbol of naval power, the seeds of further transformation had already been sown. Experiments with naval aviation during the conflict, launching aircraft from platforms or modified ships, hinted at possibilities that would soon eclipse the battleship's reign. The idea of using ships as mobile air bases took root slowly at first, with the first successful launch and recovery of an aircraft from a United States Navy ship occurring in 1910. By the war's end, the feasibility and potential of aircraft carriers were becoming clear to naval planners on both sides of the Atlantic. The interwar years were marked by both innovation and uncertainty. Treaty restrictions limited the construction of the largest battleships, but aircraft carrier development continued, often under the guise of experimentation. Navies sought ways to integrate aircraft into fleet tactics, testing their ability to scout, strike, and defend. The evolution of the carrier was steady, from early conversions of existing hulls to purpose-built vessels designed for speed, range, and efficient handling of aircraft. The rise of the carrier was not without skeptics. Many still believed in the primacy of the big gun and the armored citadel, but the logic of air power at sea became increasingly difficult to ignore. When the Second World War erupted, the transformation of fleet warfare accelerated at breathtaking speed. The early years of the conflict saw the full flowering of technologies first glimpsed in the previous war. Submarines, now built in vast numbers and equipped with improved torpedoes and sensors, once again threatened to sever supply lines. The emergence of a naval industrial complex, especially in submarine production, marked a new level of cooperation between industry and the military. In the United States, this meant not only mass-producing submarines but also integrating new forms of weaponry such as improved mines and, by war's end, the earliest guided missiles. Yet it was the aircraft carrier that emerged as the decisive instrument of naval power. By the time of battles like Midway and Leyte Gulf, the carrier had supplanted the battleship as the centerpiece of fleet action. At Midway, a handful of American carriers, guided by intelligence, launched waves of aircraft that crippled the Japanese fleet and shifted the balance of the Pacific War. At Leyte Gulf, the largest naval battle in history, carriers launched hundreds of aircraft in coordinated attacks that overwhelmed enemy defenses and secured American control of vital sea lanes. These battles demonstrated that control of the air meant control of the sea, and that the ability to project power at a distance, striking ships and shore targets alike, had become the new currency of naval warfare. The interplay between innovation and strategy was evident everywhere. Advances in radio and radar allowed fleets to coordinate operations in real time, transforming the tempo of battle and the reliability of reconnaissance. The rapid evolution of anti-aircraft weapons, driven by the need to defend against aerial attack, further altered the balance between offense and defense. New tactics emerged as fleets learned to operate as integrated systems, combining carriers, escorts, submarines, and logistics ships in tightly coordinated task forces. The lessons of the world wars at sea were clear, if sobering. Industrialization had made naval warfare a contest not only of tactics and courage, but of economic resilience and technological ingenuity. Sea power was no longer measured solely by the number of battleships in the line, but by the flexibility, reach, and sustainability of the fleet as a whole. The ability to disrupt or defend global trade became a central pillar of strategy, recognizing that the fate of armies and nations often hinged on what could be delivered or denied across the world's oceans. By the close of the Second World War, the contours of modern fleet warfare were unmistakable. The era of the battleship had given way to that of the carrier, the submarine, and soon the missile. The seas were no longer the exclusive domain of surface ships. They had become a three-dimensional battle space, contested above, on, and below the waves. Fleets that adapted, innovated, and integrated new technologies into their strategies thrived, while those that clung to old doctrines found themselves outmaneuvered and outgunned. The world's oceans, once the stage for wooden ships and cannon smoke, had become the arena for a new kind of war, one shaped by steel, strategy, and the relentless advance of technology. The end of the Second World War ushered in an era of relentless innovation and shifting paradigms for fleet warfare. The oceans, once dominated by steel hulls and roaring engines, would soon be transformed by forces far more potent and elusive: the missile, the atom, and the invisible web of digital information. In this new age, the fleet is no longer simply an assembly of ships sailing into battle, but a sprawling, adaptive network. One that must contend with the speed of hypersonic weapons, the reach of nuclear propulsion, and the complexity of both traditional and asymmetric threats. At the heart of post-war naval evolution stands the guided missile. While wartime experiments hinted at the promise of remote attack, it was only in the following decades that navies fully embraced missiles as the defining weapons of modern fleet combat. Early anti-ship missiles extended the striking range of surface vessels and submarines, but it is the emergence of hypersonic missiles that has most dramatically altered the calculus of naval warfare. These weapons, traveling at speeds well beyond Mach 5, compress decision times to mere seconds and challenge even the most advanced defensive systems. Their ability to maneuver unpredictably and strike from over the horizon has forced navies to rethink the very nature of fleet defense. Modern conflicts have repeatedly shown how precision-guided missiles can cripple capital ships and disrupt entire formations, making them not only tools of destruction but also instruments of strategic deterrence. As missile technology advanced, so too did the means of propulsion powering the world's most formidable warships. Nuclear energy, once the preserve of submarines prowling quietly beneath the waves, found its place atop the world's oceans. The introduction of nuclear propulsion revolutionized the endurance and operational reach of fleets. Nuclear-powered vessels, freed from the need for frequent refueling, can remain at sea for months on end, projecting presence and power across vast distances. Aircraft carriers and submarines became the principal beneficiaries of this transformation, their reactors providing not only propulsion, but also the electrical power needed to sustain advanced sensors, weapons, and command systems. The strategic and logistical advantages of nuclear energy are profound. Fleets powered by the atom can operate with a freedom and unpredictability unimaginable in the days of oil-fired engines. They can dash across oceans, remain on station in remote regions, and support sustained air operations without relying on fragile supply chains. While the challenges of developing and maintaining nuclear-powered surface warships are significant, ranging from technical complexity to questions of safety and cost, the nuclear navy has proven essential for states determined to maintain credible maritime dominance. In recent years, this has included not only the United States but also Russia, China, and a handful of other nations, each seeking to leverage nuclear propulsion for strategic advantage. Yet raw power is no longer enough. The digital revolution has swept across naval warfare just as thoroughly as it has reshaped life on land. Modern fleets are now woven together by intricate networks of sensors, computers, and communication links. This paradigm, often described as network-centric warfare, envisions the fleet as a single, distributed organism, where information is gathered, shared, and exploited at unprecedented speed. Ships, aircraft, submarines, and even unmanned vehicles feed data into the network, allowing commanders to form a real-time, comprehensive picture of the battlespace. The goal is information dominance, the ability to see farther, react faster, and coordinate more effectively than any adversary. The integration of digital systems has transformed both tactics and strategy. A warship's sensors can now be linked with those of distant satellites, land bases, or allied vessels, blurring the lines between individual platforms and the wider fleet. The United States Navy's Information Technology 21 strategy, for example, sought to harness this connectivity to create flexible, resilient forces capable of responding to threats anywhere in the world. In practice, network-centric operations have enabled navies to coordinate missile strikes, share targeting data, and defend against incoming attacks with a speed and precision that would have seemed miraculous to earlier generations of sailors. At the same time, this new digital dependency introduces its own vulnerabilities. The more tightly fleets are networked, the more exposed they become to electronic warfare, cyber attacks, and the disruption of communications. As navies strive for information superiority, they must also guard against the very real threat that adversaries could blind, confuse, or paralyze their forces by targeting the networks on which they depend. This interplay of technology, power, and information has shaped not only the composition of fleets, but also their doctrines and missions. In the contemporary era, navies must grapple with an array of threats that defy easy categorization. The rise of asymmetric warfare, where non-state actors or smaller nations employ unconventional tactics and weapons, poses unique challenges to even the most advanced fleets. Fast boats, unmanned surface and aerial vehicles, and special operations forces can exploit the gaps and seams in traditional defenses, striking where fleets are least prepared. The recent proliferation of containerized payloads, modular sensors, and weapons that can be rapidly deployed on a variety of platforms has further complicated the threat landscape, allowing adversaries to field lethal capabilities without the need for large, expensive warships. In response, naval doctrine has evolved to emphasize agility, adaptability, and layered defense. The United States Navy, for example, has articulated the need to maintain an agile force posture, capable of responding to both high-end and irregular threats. This includes integrating unmanned systems, leveraging artificial intelligence, and developing new concepts for distributed operations. The recognition that asymmetric tactics can threaten even the most powerful fleets has led to a renewed focus on innovation and flexibility, qualities that have always distinguished successful maritime powers. Despite the challenges, the enduring significance of fleets in global security remains clear. Control of the sea is still essential for protecting commerce, projecting national power, and securing vital interests. The oceans remain the world's highways for trade, energy, and information, and the ability to command those highways confers immense strategic leverage. This is especially true in the context of rising competition among major powers. The United States and China, for example, both view maritime dominance as central to their security and prosperity. The contest for sea control, once the domain of battleships and carriers, now plays out through a complex interplay of missiles, networks, and new operational concepts. The aircraft carrier, whose relevance has often been questioned in the face of missile threats, continues to play a vital role in power projection and diplomacy. Its ability to launch and recover aircraft far from land remains unmatched, providing a flexible tool for deterrence, crisis response, and sustained operations. While carriers face new dangers from hypersonic and cruise missiles, ongoing adaptations in defensive systems and operational doctrine have preserved their utility as symbols and instruments of maritime power. Naval innovations have also spilled over into civilian life, as technologies developed for fleet operations find new applications ashore. From satellite navigation to containerization and advanced communications, the fruits of naval research have transformed global commerce and society. The symbiosis between military and civilian maritime technology is a reminder of the enduring influence of sea power on the wider world. As the 21st century unfolds, the horizons of fleet warfare continue to expand. The oceans are contested not only by surface ships and submarines, but also by invisible networks, autonomous platforms, and weapons that move at unimaginable speeds. The core missions, protecting commerce, deterring aggression, and projecting strength, endure, but the means by which they are accomplished are in constant flux. Navies must balance tradition with innovation, mass with precision, and centralized control with distributed resilience. In this modern age, the fleet is not merely a collection of ships, but a living system, adaptable, networked, and ever vigilant. Its future will be shaped by the relentless march of technology, the shifting tides of geopolitics, and the age-old imperative to command the seas. While the tools and tactics may change, the fundamental importance of maritime power remains as vital as ever, anchoring the security and prosperity of nations in an uncertain world.